Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. OsO4 performs syn-dihydroxylation of alkenes, adding two OH groups to the same face of the double bond. The substrate is 2-cyclohexane, 1-ol, which has an OH group on a wedge, equatorial axial, at C1 and a double bond between C2 and C3. Moving on to the next step. The starting material is R2-cyclohexane 1-ol or S, but the OH is drawn on a wedge at C1, meaning the hydroxyl at C1 is on the top face of the ring. Moving on to the next step. OsO4 adds syn to the double bond, both OH groups added to the same face. The existing OH at C1 can direct the OsO4 reagent through a directed dihydroxylation, hydroxyl-directed OsO4 addition. The OH at C1 coordinates or sterically directs OsO4 to approach from the same face as the C1 OH top face, giving syn addition of the two new OH groups on the same face as the existing OH. And for the final step, directed syn-dihydroxylation from the same face as the C1 OH top wedge face gives a product where C1 OH is wedge and C2 OH and C3 OH are also added from the top face. Since OsO4 adds syn, both C2 and C3 OH groups are on the same face, top face, same as C1 OH. This gives 1,2,3-cyclohexanetriol with all three OH groups on the same face, all CIS, C1 OH on wedge, C2 OH on wedge dash depending on ring geometry. Option A shows cyclohexane 1, 2, 3 triol with OH at C1 on wedge and OH groups at C2 and C3 on dashes, hashed wedges pointing down back. In a cyclohexane ring drawn flat, if C1 OH is on a wedge, up, and C2, C3 OH are on dashes, this represents all three OH groups being on the same face, since the ring connectivity means dash at C2 adjacent to wedge at C1 can still be CIS depending on ring orientation. The major product, X, ratio 12:1, is the directed syn addition product where OsO4 approaches from the face of the existing C1 OH, giving all three OH groups CIS. This is option A. Option B shows C2 and C3 OH on bold wedges same side as C1 OH, but this would represent the product from attack on the opposite face, anti to directing group, which is the minor product Y. Option C shows an epoxide with OH, not a dihydroxylation product. Option D shows a simple epoxide without OH, not a dihydroxylation product, and OsO4 does not form epoxides. Therefore, the correct answer is A. Therefore, the correct answer is option A.